So welcome. So already to discuss about the mechanical transfer system in our previous video, previous session. So now we have to discuss about the next one more problem in same manner in a mechanical translation system. So that we will go for the problem. Problem number 2. Determine the transfer function y of s by f of s of the system shown in figure. So the figure represents starting from the reference point. The f of t is a force. It is a downward directions. So then y1, then y2. These are two information in the same directions. From it is equally on the force directions. Then k1, k2 are the spring value, m1, m2 are mass value. Then b is our friction points. So we have to segregate two separate portions, M1 and M2 portions. First of all, we have to discuss about the M1 parameter value. So M1 is the first term. The F of T is the incoming force. Then with the Y1 direction, the opposing forces are F of M1, the mass force, then K1 friction force, then F1 dash 1 force, then F of K2 force. So K1 and K2, the two spring values are acting in the same M1 point. So we have to discuss the four informations from the equation term. So the overall F of T is equal to Fm1 plus Fk1 plus Fk2 plus Fb. These are the general formula from the mass 1 parameters. So after the calculating these equations, we have to submit the notation terms. Fm1 means we have to submit the m1 mass value with the direction of, with the second order equation, d square y1 by dt square. This is for second order equation term. Then Fb term means it is b into dy1 by dt plus k1 into y1. This is for the k1 value. Then k2, the k2 it is indicate, so it between the y1 and y2. So we have to put the maximum minus minimum value. So y1 minus y2. This is for the right way. This is for the right way of the mass terms. So after the conversion term, you have to take in the Laplace functions. So first function, that means mass function, it is a second order function. So it is convert s square into y1 of s. Then b, the coefficient term, that is indicate single first order derivative function. It comes to s into y1 of s. Then friction value, spring value, y1 minus y2, it is it comes out y1 of s minus y2 of s. So substituting all the values in our equations, we get the final term f of s equal to m1 into s square into y1 of s plus b into s into y1 of s plus k1 into y1 of s plus k2 into y1 of s minus y2 of s. These are the informations from taking after the taking Laplace equations. Then we have to segregate the equations. Then that means y1 of s value, y2 of s value. Separate the both the equations. So finally we get the f of s is equal to m1 into s square plus b into s plus k1 plus k2 into overall the value of y1 of s minus k2 into y2 of s. That is equation number 5. So these informations are getting from the mass m1 value. After we have to get we have to consider about the second parameter section, that means mass 2. It is input of the force equation is 0. the direction is y2, but it is opposing forces two parameters. That means individual the self value, that is Fm2 and Fk2. This is the two opposing forces are present here. So that is 0 equal to Fm2 plus Fk2 value. That is equation number 6. So substituting the significant notations, m2 into d square y2 by dt square plus k2 into y2 minus y1. Here, as usual procedure, the k2 is placed in between the y1 and y2. Therefore, substituting maximum minus minimum value. So y2 here, the y2 is the maximum value, y1 is the minimum value. So that we have putting the value of y2 minus y1. So taking the Laplace equation, after the Laplace equation, we have to substitute 0 equal to m2 into s square into y2 of s plus k2 into y2 of s minus y1 of s. This is equation number 8. So rearrange the equation, and after the rearrangement, 0 equal to m2 of s plus k2 into y2 of s minus k2 into y1 of s. So this is the equation number 10. So from the equation number 5 and from the equation number 10, we have to present y1 and y2 separations. So here k2 into y1 of s is present. So you have to come around the left hand side equation. So k2 into y1 of s is equal to m2 s square plus k2 into y1 of s. So therefore y1 of s is equal to m2 s square plus k2 into y2 of s by k2. So this is the equation of y1 of s term. Substitute the term in the equation number 5. So that is f of s is equal to m1 s square plus k2 by k2 into m1 s square plus bs plus k1 plus k2 whole value minus whole value into y2 of s minus k2 into y2 of s. So after taking Laplace, after taking the LCM equation, then rearrange the formations, we get f of s is equal to m2 into s square plus k2 into m1 s square plus bs plus k1 plus k2 minus k2 square of y2 of s. So by k2, this is the overall equation from the f of s value. So finally we get the equation of y2 of s by f of s. This is the transfer function equation. So rearrange the equation. Therefore transfer function is equal to y2 of s by f of s is equal to k2 by m2 s square plus k2 into m1 s square plus b into s plus k1 plus k2 minus k2 square. So this is for the corresponding problems transfer function equation. So we are discuss about mechanical translational systems. So in the two problems. So in the next session, we have to discuss about the mechanical rotational systems. Thank you.